Good morning, good morning, good morning, or good afternoon. It is time for us to go ahead and get the ball rolling with our math lesson today. We are going to continue equivalent fractions. We are going to continue to find equivalent fractions. That's our goal for today. That's our objective. And I know for sure that we are ready to roll.
Understand equivalent fractions, then working with fractions is pretty easy. Well, what are they? Equivalent fractions are fractions that name the same amount. So here you have two fractions, one half and two fourths, and they're naming the same part of that circle. One half and two fourths are equivalent fractions. They're naming the same thing. Now, when you're writing equivalent fractions, it's pretty easy if you can remember the identity property of multiplication, which states that any number times 1 will give you that same number. Its identity doesn't change. For example, if you multiply 6 times 1, you're still going to get 6. The 6 doesn't change. You multiply 1 half times 1, you're going to get 1 half. If you multiply anything by 1, its identity won't change. You'll end up with the original number. Well, that's real important. All of these fractions here are equal to 1. 11 11s, 5 fifths, and so on. All of these equal 1, which means if we multiplied something times these fractions, it won't change the identity of that number. For example, if we took 2/3, all of these fractions right here
are the same as 1.
Are the same
you're multiplying
as 1.
times 1.
Like you're multiplying times 1, which means you're not changing
the identity of
the original number.
2/3 is
2/3
equal to 22 over 33.
22 over 33.
2/3 is equal to 14 21st.
14 21st.
2 times 7 is 14.
2 times 7 is 14. 3 times 7 is 21. These are equivalent fractions. If you multiply 2 times 5 and get 10, 3 times 5 and get 15,
2/3 and
10 15
are equivalent fractions.
And that last example,
when you're multiplying
by 3/3, it's like you're multiplying by 1.
You're really not
changing the identity
of 2/3.
2/3 is equal
to 6
to
ninths.
6 ninths.
In fact,
all these fractions
down here
that
we've
created,
they're all
equivalent fractions. They're all naming the same thing.
So if your
teacher
teacher
asked you
to
to
write
write
4
4 different equivalent fractions for 3/8,
be
be easy.
we could
We could
multiply
multiply
it
it
3/8 times 2 over 2, which is just like multiplying by 1. We're not changing 3/8's value. 3
3
times
2
is
is 6.
8
8
times 2
2
is
is
16.
16.
6
16
is an
is an
equivalent
equivalent fraction to
3/8.
3/8.
What
What
about
if we multiplied it times 4 over 4?
3
3
times
times
4
4
would
would
be
be
12,
12,
and 8
and 8
times
times
4
4
would be
would be
32.
32.
Ladies and gentlemen, if you aren't sure on your multiplication, please use your multiplication chart as we continue to work on our multiplication skills. Notice as he's identifying the equivalent fractions, the numerator and the denominator have to be the same. So 3 over 8 times 2, the numerator is 2, and the denominator. It has to be the same when we're trying to find or identify equivalent fractions. Let's keep going.
30 seconds is an equivalent fraction to 3/8. What if we did 10 over 10?
10 over 10,
Which is the same as 1.
one.
That would be 30,
That would be 30
over 80.
over 80.
3/8 and
3/8
30
and 30 eightieths
are equivalent fractions.
fractions.
And what about
if we did how about 10,000 over 10,000?
Which is
Which is equivalent to 1. It's like multiplying times 1.
That would
That
give
would give
us
us
30,000
30,000
over
over
80,000.
80,000.
That's an
That's an
equivalent
equivalent
fraction
fraction
to
to
3/8.
3/8. So we just made
4
4
fractions
fractions
that
that
are
are
equivalent
equivalent
to
to
3/8.
3/8.
Really,
Also, take note, we did not add, subtract, or divide to find these equivalent fractions. We multiplied. So to find 4 different equivalent fractions, you have to multiply by the same numerator and the same denominator. Go ahead, take notes on this slide. Write this down for your information. We're going to multiply the same numerator and same denominator to find an equivalent fraction for any fraction. This example is 3/8, but we could take any fraction and multiply it by the same numerator and same denominator to find another equivalent fraction. When you think of equivalent, think back to our circles. When all of the fractions were different, but the amount that we shaded, the amount that we colored was still the same. Keep that in mind. For today's assignment, you will also need fraction circles. When you look on your announcement in Schoology, you go to your Black Math course and your days of the week pop up, click on fraction circles. When you click fraction circles, you can see an interactive fraction circle that we are going to use today. Make sure that you keep this tab open. We're going to come back to it. When your fraction circles are open, don't close that tab. Leave it open. You're ready to begin Tuesday's assignment. Tuesday. Right below your agenda, you have Unit 3, December 8th. Today is December 8th, and we are continuing to work in Unit 3. We are continuing to work in Unit 3. I'm going to show you that one more time right under your agenda, Unit 3, December 8th. Wait for your page to load, and then open the assignment with Cami. It takes just a moment to load, but that's okay. We are patient. For this assignment, we're going to start keeping in mind that our fractions are just a small part of a circle, small part of a number line that we saw yesterday. What we're going to do first is to write the missing fractions on the number line. Our denominator is how many segments our line has. How many pieces do we have on our line? That's our denominator. Denominator, again, is our bottom number. Our numerator is our top number. Think of that as our shaded area when we're at our circles. Let's start with this number line. First, I'm going to write my denominator. How many segments do I have on this line? How many pieces? Yes, 2. There's 1 and then 2. So I have 2 pieces, 2 segments on this line. To write the missing fraction, I'm going to see where the line falls. When I jump, there is 1 jump. So one part is shaded. One part is shaded. I only jumped 1 spot to get to this first line I have to identify. My denominator is 2 because I have 2 segments total, 2 pieces, 1, 2. Those are my 2 pieces of the line. But I only jumped to 1. The line stops after the first jump. My fraction is 1/2. Let's keep going. Write the missing fractions on the number line. This time, how many pieces do we have to this line? If you said 4, you are absolutely correct. 1 segment, 2, 3, 4. And we are going to write the fraction for each mark here that we have on this line. On the first one, how many times do we jump from 0? How many segments do we have? Yes. I'm going to use a different color so it's not as confusing. 1. So that's my numerator, my top number. And how many sections do I have total for my denominator? That's right, 4. Our first missing fraction is 1/4. 1/4. This is only one out of the 4 sections that we have on our line. For the next one, I'm going to use a different color. 1, 2. I jump 2 sections. That's my numerator. And my denominator is how many sections I have total. How many sections do I have again? That's right, 4. 4 sections total. This line stops at the second section. 2/4, 2 out of 4. What about for the last one? 1, 2, 3. My numerator is 3. My numerator is 3. And what's my denominator? Yes, 4. 3/4 is the missing fraction on that number line. I know there are more fractions that we have to identify, but now we know what to do. The first thing we're going to do is count how many sections we have on this number line. Total, because the total amount will be my what? Numerator or denominator? Yes, it will be my denominator. So let's find our denominator, our bottom number. 1, 2, 3, 4, 5, 6. All right, I know my denominator is going to be 6. If I can't read your numbers, please use the text box. When you use the drawing tool and you write your numbers, if they aren't legible, if I can't clearly read them, please use the text box. Okay, back to this. For our first line, 1. My numerator is 1/6. 1/6. What about for the second one? What's my second missing fraction? Yes, 2. 1, 2. I have 2 segments, 2 pieces of my line. Over. How many sections do I have total? Yes, 6. Keep going. You will fill in these last 3 on your own. Remember, count 1, 2. That's what we did. Your denominator is 6. Will your denominator be 6 as well? Yes, you better believe it. You're finding the numerator. Okay, you got this. Pause this video so you can complete those 3 missing fractions on this number line. Once you've finished, now here's that tab that I asked you to open earlier. Remember this? So, hey guys, you will need this interactive fraction circles. You will need this. If you don't have this tab open, maybe you forgot, or if you accidentally closed it, go back to your home screen in Schoology and click on fraction circles. Click on fraction circles. When you click fraction circles, then this is the tab that will open up, and this is what we're going to use right now. Now that you have that tab open, let's talk about how we're going to use it. Use fraction circles to identify fractions that are equivalent to 1/2. Circle the fractions that are equivalent to 1/2. Now, our video that we watched earlier will help us to find equivalent fractions as well. If our fraction is 1/2 and we multiply the numerator and the denominator by 2, it has to be the same number, remember. If you don't remember, go back to the beginning of this video to rewatch the first video that we saw together. 1 times 2 equals 3. 2 times 2 equals 6. By multiplying this fraction 1/2 by 2, numerator and denominator, our answer was 3/6. So we know 3/6 is equivalent to 1/2. We know 3/6 is equivalent to 1/2. So we would circle 3/6. What if you don't remember this way? That you don't want to go through and multiply 1/2 times 2, 1/2 times 3, 1/2 times 4? That's okay. Let's go to our circles. And we want to find out if 6/12, 6 over 12, is equivalent to 1/2. We want to find out if 6/12 is equivalent to this 1/2. You might look at 6/12 and know right away, okay, Miss Adams, if my fraction is 1/2, I know if I multiply 1 times 6 equals 6, and 2 times 6 equals 12. Yes, that's equivalent. It's equal. They're the same. I would circle it. If you don't, let's go use these fraction circles. And I want to find out if 6/12 is equivalent, if it's the same amount of this circle as 1/2. First things first, let me get 1/2. 1 over 2, 1/2. Now 6/12. My bottom number is 12. There you go. So I need 6 of these pieces. 1, 2, 3, 4, 5, 6. Is the same amount of the area covered in a circle? Yes. So I know 6/12 is equivalent. It's equal to 1/2. It's equal to 1/2. Because when I look on my fraction circles, the same amount is shaded for 1/2 and 6/12. 1, 2, 3, 4, 5, 6. Let's look at our next problem, 5/10. Let's see if 5/10 is equivalent or equal to 1/2. I'm going to use my fraction circles. Get those out of the way. I'm going to keep 1/2 because I'm trying to see if 5/10. Here are my tenths. 1, 2, 3, 4, 5. Is the same amount of that area covered on the circle? Yes, the same amount is covered, so it is equivalent. And I'm circling the fractions that are equivalent to 1/2. I'm going to circle 5/10. I'm circling that because when I look at my fraction circles, the same amount is shaded. The same amount of that area is shaded. Or if I want to use my multiplication, I know that 1 times 5 equals, I'm going to delete our 6 because we're finished with that one. 1 times 5 equals, yes, 5. And 2 times 5 equals, you got it, 10. Because I can multiply the numerator and denominator by the same number, 5, 5/10 is equivalent. Don't get confused, guys. I'm just showing you 2 different ways to do this. You can multiply or use your fraction circles. If you want to do both to double check yourself, be my guest. Be my guest. But you can multiply Same numerator, same denominator, or use your fraction circles to find the equivalent fractions. Let's keep going. I'm going to erase this so it's not confusing. Okay. Is 3/4 equivalent or equal to 1/2? 3/4, is that equivalent to 1/2? I'm going to use my fraction circles. 3/4. So here's my fourth piece. And I need how many of those? 3. 1, 2, 3. Uh-oh. Is the same amount shaded? No. 3/4 is greater than 1/2. There's more area shaded in 3/4 than there is 1/2. Because of that, I am not going to circle that fraction. It's not equal to 1/2. It's greater than. Three-fourths is greater than. There's more area shaded on this circle, my 3/4, than there is on 1/2. If I multiplied 1 times 3 equals 3, and I multiplied 2 times 3 would equal 6. So it'd have to be 3/6 like we already have, not 3/4. Finally, ladies and gentlemen, let's look at 5/6. Do you think 5/6 is equivalent to 1/2? Let's use our fraction circles. I'm going to find my sixth piece. Here it is. And I needed 5 of those. 1, 2, 3, 4, 5. Is that equivalent or equal? Is the same amount shaded? No. Nope. Which one has more of a shaded area? Yes, 5/6. So we know that is not equivalent. You may be thinking, well, I knew that, Miss Adams, without looking at my circle, because I already have 5 as my numerator. And I know the denominator has to be 10 because 1 times 5 equals 5 and 2 times 5 equals 10. So I knew that wasn't going to work. Well, way to go, smarty pants. So again, we use 2 different ways to identify fractions that are equivalent. We multiplied our numerator and denominator by the same number, or we were able to use our fraction circles. Find what works best for you, as long as we definitely understand. Speaking of understanding, let's use these fraction circles again to find and name 2 fractions that are equivalent to 1/3. We're finding 2 fractions that are equivalent to 1/3. Keep that in mind. I am refreshing my fraction circle so they're both blank. And I'm finding fractions that are equivalent to 1/3. I'm putting 1/3 up here. And I want to find which pieces will equal the same shaded area as 1/3. Let's see. Let's start with our 4th. Oh, that's not going to work because more area is covered. Maybe our 5th. Nope, that's not going to work. More area is covered. How about 6th? What do you think? Not 3/6. Yes, 2/6. We use 2 of our 1/6 pieces. So we know that 2/6 is equivalent to 1/3. We know that 2/6 is equivalent to 1/3. To check yourself, let's multiply. 1 times what equals 2? 1 times 2 equals 2. And what about 3 times 2? Yes, 6. So we know that 2/6 is equivalent to 1/3. That's how we use our fraction circles. If you want, instead of your fraction circles, show your work and show me how you are finding fractions that are equivalent. For example, 1/3 times, we already used 2. What's the same numerator and denominator we can use? Okay, let's go with 3. 1 times 3 equals 3. 3 times 3 equals 9. So a fraction that is equivalent to 1/3 is 3/9. As long as we are multiplying the fraction with the same numerator and same denominator, it's going to be equivalent. What if we multiplied 1/3 by 2/4? Is that going to be equivalent? No. We need the same numerator and same denominator. If 4 is our denominator, then we need to use 4 as our numerator. 1 times 4 equals 4. And 4 times 3 equals 12. So 4/12 is another equivalent fraction for 1/3. Use what works best for you. If you want to multiply or use your circles, you can, but we're making sure the same area is shaded. The only thing that changes is how many pieces that we're breaking this circle into. That's how we're finding our equivalent fractions. For this last page, find and name 2 fractions that are equivalent to 2/5. Again, multiply with the same numerator or denominator and tell me one equivalent fraction, or use your fraction circles. And if you choose to use your fraction circles, then your first circle, 2/5, was 1/5, 2/5. That's how you would start it. What other pieces are you using to shade the same area? 2 different ways, but as long as we know how to find fractions that are equivalent, that's our objective today. Once you finish, please submit. That's all she wrote on our fractions. If you have any questions, please, please, please let me know. And I know that you are rocking out fractions right now.